welcome to this new tutorial on Emgu CV. In this tutorial, I am going to show you how we can perform face detection using Cascade Classifiers. So the objective is to use Haar and local binary pattern Cascade Classifiers for face detection. Additionally, I'll show you how we can detect eyes using Haar Cascade Classifier. So the dataset that I'm going to use in this tutorial is available as part of OpenCV on the GitHub repository. These are the XML files which are created by training the OpenCV face detection engine on face and non-face images. It can be used to detect faces from still images, videos, or even from live camera feeds. One more thing that you should keep in mind is the difference between the face detection and face recognition. Face detection is more relevant to finding the face within an image, while the recognition is to identify whose image is that. So in this tutorial, I'll be focusing on face detection, and in a later video we will focus on how we can actually recognize the detected faces. So let's get started. I have already created a project and I configured it to use Emgu CV 3.3. If you're not sure how to configure it, you can check one of my previous videos. So right click on the project and add a form to it. Go to add and you can select the Windows form. Give it a name, form face detection for example, and click on add. This will create this form. Let me resize it and add some controls from this. The first thing that I need is a menu control, so I'll drag and drop a menu and a simple picture box. That's it. So let me dock it to the parent, and from the menu I just need to save file. This is for opening the image, and then detect face, Haar Cascade Classifier, and one for detect face, local binary pattern. So let's click on this open, double click on that. So the first thing that I need to do is to include this Emgu CV in my project. So using emgu.cv, optionally you can just press Ctrl and C, then enter, and again Ctrl V. And I need to add the structure as well. Now in this event I want to open an image, ask the user to open an image, and I have created basically a code snippet, OpenFileDialog, I call it OFD, and double tap, it will generate this code for me. I'll provide the code snippet that I have written for this OpenFileDialog if you want to use it. To include it in your Visual Studios, you need to go to Tools and Code Snippet Manager, and from here you need to select the C# and then click on Import, and wherever you put it, for example I put it here, right? Yeah, I have written 4 code snippets, and you can click it and open it, and then it will be available for you to use. So instead of writing all this repeatedly, I just created it once and I'm using it. So the first thing that I need to do is to create a class member of type image and BGR of type byte. I call this one as Img input. And what I will do here is, once the user selects an image, I want to read it into this Img input. The way is to create an object for it and pass as a parameter the name of the file that has been selected by the user. And once it is read into this Img input, I can show it in picture box 1, so that I picture box 1.image equals Img input. And since it is expecting an image, so I need to take this bitmap image from the image input. So this one will display the image in my picture box. So double click on detect face Haar, and here I have created another code snippet for try cage, and I call it try. And here the first thing I need to make sure is the img input is not null. If it is null, if it is null, I should throw an exception, new exception class, please select an image. Now why I am throwing the exception here, so that I catch it right here and display it as a message. If it is not, if the image has been selected, then this code will be executed. Maybe I can create a new function to implement the Haar cascade. It's always a good practice to localize unique functions in unique words or tasks in separate functions. So let me create a function quickly, public void and detect face Haar. So if I click on the face detect button using Haar, then I should call this function simply. First it will make a check, and then it will call this function. Inside this function, I'll be implementing the code required for face detection using the Haar. To use the Cascade classifiers, we need the data. So let's go and get the data first. You can write in the Google OpenCV GitHub. And here you go. On the GitHub, you can go to this data folder, and here you can see a Haar cascade and LBP cascade. So I'm going into this Haar cascade classifier, and you will see a lot of XML files. So I will be using this Haar cascade frontal face default for face detection. You can just right click on open in a new tab, and also we can use this Haar cascade i.xml. Once you open these files, you can click on the raw, and this one will open the raw XML file. You can right click on this, save as, and then you can save it at any location you want. Similarly for this one, you can click on raw, and this is the Haar cascade, and you can save it anywhere you want. Similarly for the, this is for the Haar cascade. Also I'll be showing you the LBP cascade, and I'll be using this LBP cascade frontal face. Remember that there is another one, frontal gate face. Interestingly, I downloaded this frontal cascade and tried on my own face for detection, but it failed, and I was surprised, and then I came to know that it is basically frontal gate face. So you have to download the right XML file. So similarly, you can go to the raw and right click on it and save it anywhere you want. I created a folder named data inside my project and place these files inside it. So you can also create a folder anywhere. You need to provide the path for these files. So let's use these files to train our Cascade classifier. So I'll be using this my custom code snippet just to create this code. And here I can say exception. What kind of exception we have? Message. Okay. The first thing that I need to read those XML files, so I call it face path. I need to use is I can use the path. So the path is not available, it is available in using system.io. So I will say get path, full path, and which full path I want to get it is I just want to move one folder into the parent, once again into the parent. It means I am moving out of this folder first and then this folder so that I get this path. and then I can move into data folder, and inside my data folder I have this Haar Cascade frontal face. Copy this and paste it right there. Now we can create an object of the Cascade classifier. Cascade classifier, I just call it classifier equals new Cascade classifier. It has a default constructor, as well as we can provide the name of the file that contains the Cascade classifier training file. So I can pass this file path into it. The next thing that I need to do is to convert this RGB image into a grayscale image, as this Cascade classifier expects a grayscale image for face detection. So I will do something like this: img gray equals to img input dot convert into a grayscale and of type byte, and maybe I create a clone copy of it and assign it to img gray. So now I can use the classifier face dot detect multiscale, and this one is expecting an img gray image as input. The scaling factor is basically determines what should be the size of the window on each iteration, or when we perform rescaling. I say by default is 1.1, which indicates a 10% increase. If you decrease this value, the results may be more perfect, but it will take more time. And the minimum neighbors by default is 3. I can say let's try with the 4. What does this mean is, since we are detecting the features at multiple scales, and this will determine that if we have multiple windows, the window will be accepted as if it is a face or an eye if it has a neighbor of minimum 4. So that is, in short, how can I make you understand. Okay, now look at this one is basically returning an array of rectangles. So I need to declare a rectangle array, and I call them faces, for example. So what it will do, it will, if it finds or matches the features of a face, it will return the location of this face in the form of a rectangle. So if there are multiple faces, that's why it has an array. Now the next thing is I need to loop through these faces. If there are, then I can display them on my input image. So for each, I'll be using for each variable face in faces. I want to do img input dot draw. On the input image, I want to draw these rectangles, faces, face, and I need to provide some other parameters. I will show you for this. Where is rectangle? Yes, rectangle, we need to provide the color of it. Let's say 0, 0 to 55. This is the red color, and the thickness, let's say 2. It's okay. And that's done. And in the last, I can show you picture box dot image equals img input dot bitmap. That is great. So let's try and check if it is working fine so far or not. So go to File, Open. Let me try on my own face first. File and detect face. Wow, perfect. And let's try on Mr. Ray's. Wow, it works fine. Let's try Mr. Imran Khan. It looks like it is working fine. I mean, let's try a group of people. Detect. Perfect. And even more people, for example, if it can detect their faces. Wow. This is the Vitra volleyball team, and let's try with Samina the mountaineer. And I am surprised that I can see someone detected in the background as well. So this is the Haar for you, and so far I think it's working perfectly fine. So after this was for the face detection. The first we read the XML file, created the object for the classifier, and since it expects a grayscale image, so we converted the RGB image, and then we used the detect multiscale method of this classifier, Cascade Classifier, and provided this image, the scale, and the minimum number of neighbors, and it will return us a rectangle array if there are faces, more than one face, of course, then, and those will be assigned to these faces, and we loop through these faces and draw them one by one on this input image and finally display them. Now my next objective is, let me align these things. The next objective is, if there are eyes, of course, in a face, if we have a face, there should be eyes. How can we detect those eyes? So ideally, what can we do is we can check on the whole image for eyes, but it is, logically incorrect. Once we have the face, we should look for the eyes inside the face. So I'll be doing something inside this code inside this for each loop to look for. We will again use this Cascade Classifiers inside this face to find the eyes. So how we can do that? The first thing that I need to do is make a Control-C, Control-V, and I just call it eye path. That was for face, and over here the name of the file is Cascade eye. So I just copy that and paste it right here, and I will also copy this one and paste it right here, and I just call it classifier I and pass this as the path. So we have the we will train our Cascade Classifier using the file that we have already downloaded it. Now inside this for loop, what I want to do is I want to limit my processing to this face only. So the one thing that you can do is, for this Emgucv.region of interest is equal to this rectangle, this face actually. Sorry. So now I will be working on this face only. That is, whatever this face is basically a rectangle. So on this rectangle, what I need to do is to apply the classifier I.detect multiscale Emgucv, and I use the same parameters. I have already used it. You can try with the other parameters, and at this time we are getting another rectangle, array of rectangles, and just I call it eyes. And once it will detect the eyes using this classifier I cascade, we can loop through it for each variable. I call it I in eyes collection. Now I can draw that on my input image. I just copy it and paste it, Control V, and instead of face I will have now eye. But one thing, remember, since we have limited this ROI to this rectangle, so it will consider the coordinates according to this small image, and once we draw them on this input image, since the coordinates are according to this ROI, so we will get the location in the wrong place. So to deal with that, I will create a variable, let's say E equals I assign it back, this I into E. Now what I want to do is E.x should be, basically it should be plus equals to I need to add the location of this face.x as well. What does it mean? Similarly for e.y, I need to do plus equals face.y. Since I am working on inside these rectangles, whatever the coordinates I have received are according to that small part of the picture. So to get it on the original image, I need to add this x component of the original face as well. And this one will now display the eye location on the original image in the correct location. So here I pass the e, means this is the eye that I want to draw it. So let's try it. File, open an image, detect, perfect. But I want to give it a different color so that we could differentiate between them. Let's say it's a green color for it. Let's make it 0. File, open, image. Now it's very fine. Let's try for Mr. Erdogan. Okay, his one eye looks bigger than the other. Mr. Imran Khan. Wow. Samina Bags. Can it detect? And it is very interesting that the face in the background as well as one eye is also being detected. I like it, by the way. And for multiple faces, now you can see that there are some exceptions. These people have 3 eyes. And for the Vitra, if you notice, their faces have been detected but the eyes have not been detected. It is possible depending on the position of depending on the distance between the camera and the object. So for Mr. Putin also it is perfect. And this was how we can use the Haar Cascade detector. And now let's try with the local binary pattern detector. So let me use this try catch block, and I will create a function. Basically I can copy and paste the same function, and just I name it like, instead of Haar I can say local binary pattern, and you will see what changes do I need to do. And inside it I can make a check if ng input equals null, then I can throw a new exception, no image selected, for example, and then I can call this function. Now interestingly, I don't need the others. I will remove this one. The minimum changes that you need to make is you have to select this LBP Cascade frontal face, and that's it, nothing else. And since it is not going to detect these eyes, so I just removed that part. Ideally it is the same code that we have done it before the eye detection. We have the path, we created the object for this Cascade classifier, convert the image, and then detected the faces. Now and then loop through it and display that in the picture box. Maybe I should give a different color for LBP, so that, let me say green color for it. Now how it comes to know that the Cascade classifier class that I need to use LBP or the Haar Cascade. Now if you look here, there is a feature type Haar, and for LBP pattern there is a feature type LBP. So the this class is smart enough to know which type of Cascade classifier we are using based on the XML file that we provide. So that was the only change that I did, is to change the XML file and nothing else. So let's try this. File, open my image, and let me try with the face Haar. Okay, and now you can see the blue is by the local binary pattern while the red is by the Haar detector. Let's try on other faces. This is the Haar and this is LBP. Almost both are same. Both are not missing anything right there. And in this case, let me try. So you can see perfectly. Both are working fine as far as I see on almost all these images. You can see this LBP is not for the eye detection. And let's see if the LBP can detect this background face. It missed this one, but it detected any other face from the other. So it now both are working fine on these images. And now it depends on the application where you want to use. The LBP local binary pattern is a little faster than the Haar Cascade, but you need to test it with your own data set as well, according to the information provided on the internet. But the Haar is a bit slower, but it is very robust. I mean, it gives high accuracy. So in most of the time for security applications or surveillance or any real-time applications, I mean in any such applications where accuracy is preferred, so people have used Haar Cascade detectors. So it depends on your application requirements which one to use for your own needs. So I hope to see you in the next video.